देखते हैं हॉर्स कार्ट न्यूमेरिकल. So these are application of NLM. These are application of NLM. Application of NLM. So first is horse cart numerical. Horse cart numerical. So horse cart numerical. So this is the horse that applies force on the ground. T is the tension in the string. F is the applied force. So every action has equal and opposite reaction. So this angle is theta. So this is the action, this is the reaction. This is the action, this is the reaction. So this angle is also theta. So this is n, this is theta, this is n cos theta, this is n sin theta. So this is horse. For horse, this is the facing component. N cos theta is the facing component. This is the horse. N cos theta is the facing component. Back component is the tension. So mass is capital M. Mass of the horse is capital M. Mass of the horse is capital M. Small m is the mass of the cart. So horse mass is capital M, cart mass is small m. So this is n cos theta. So back is tension and it moves with acceleration. So n cos theta minus t equals to m into a. N cos theta minus t equals to m into a. N cos theta minus t equals to m into a. So this is for horse. So next for cart. Mass of the cart is small m. Mass of the cart is small m. Mass of the cart is small m. So this is tension T. Mass of the cart is small m. This is acceleration. T equals to small m into A. Second equation, T equals to how much? T equals to small m into A. So adding 1 and 2, so adding 1 and 2, Tt gets cancelled. So n cos theta equals to A whole into capital M plus small m. So acceleration equals to how much? Acceleration equals to n cos theta divided by small m plus capital M. A equals to acceleration equals to how much? Acceleration equals to n cos theta divided by acceleration equals to n cos theta divided by capital M plus small m, that is acceleration. Acceleration equals to n cos theta divided by capital M plus small m, that is the acceleration in case of horse cart numerical. So after finding acceleration, tension equals to how much? Tension equals to how much? Tension equals to mass into acceleration. Mass acceleration is n cos theta divided by m plus m, that is the tension. Tension equals to T equals to m into n cos theta divided by capital M plus small m, that is the tension in the string. That is the tension in the string. So that is application of NLM, horse cart numerical. Next is mass pulley problem. Mass pulley problem. Horse cart problem, then mass pulley problem. For the mass pulley problem, this is the pulley arrangement. So this mass is m1, this mass is m2. T is the tension in the string. So here weight is m1g. So this weight is m2g. So m2 is greater than m1. As m2 is greater than m1, m2 moves in downward direction. m1 moves in upward direction. So this is the mass pulley numerical. So acceleration, that is the acceleration. That is the acceleration. So for m2, so this is m2g, this is t, this is acceleration. So equation, so what will be the equation? m2g minus t equals to m2a, first equation. For m1, t minus m1g equals to m1 into a, that is the second equation. So adding 1 and 2, tt gets cancelled. m2 minus m1 g equals to a divided by m1 plus m2, that is the acceleration. A equals to m2 minus m1 g divided by m1 plus m2, that is the acceleration. That is the acceleration. A equals to m2 minus m1 g divided by m1 plus m2, that is the acceleration. That is mass pulley problem. So next, for inclined motion. M1, M2. T is the tension in the string. So weight is M2 G. So this is the acceleration. Acceleration is in downward direction. For M2, what would be the equation? For M2, what would be the equation? M2G minus T. M2G minus T equals to M2A. M2G minus T equals to M2A. T equals to M1A. Second equation. M2G minus T equals to M2A. T equals to M1A. So adding 1 and 2. So adding 1 and 2, TT gets cancelled. M2G equals to A whole into M1 plus M2. That is A equals to how much? M2G divided by M1 plus M2. That is the acceleration. Acceleration equals to how much? M2G divided by M1 plus M2. That is the acceleration. That is the formula for acceleration. So this is M1. This is M2. This angle is theta 1. This angle is theta 2. T is the tension in the string. T is the tension in the string. So weight is M1G. M1G, this is theta 1. M1G cos theta 1. M1G cos theta 1. M1G sin theta 1. So this moves in this direction, this moves in this direction. This is M2G. This is theta 2. M2G cos theta 2. M2G sin theta 2. This is acceleration. So you can write M1G sin theta 1 minus T1. M1G sin theta 1 minus T1 equals to M1 into A. M1G sin theta 1 minus T equals to M1 into A. for m2 t minus m2g sin theta 2 equals to m2a. So adding 1 and 2, tt gets cancelled. m1g sin theta 1 minus m2g sin theta 2. So that is acceleration. m1g sin theta 1 minus m2g sin theta 2 divided by m1 plus m2. That is the acceleration. Acceleration equals to m1g sin theta 1 minus m2g sin theta 2 divided by m1 plus m2. That equals to acceleration. That equals to acceleration. So this is related to mass pulley. So next is motion in a lift. Next is motion in a lift. First point, lift is at rest or moves with constant speed. Lift is at rest or moves with constant speed. Lift is at rest or moves with constant speed. Lift is at rest or moves with constant speed. So weight is mg. N is normal reaction. Lift is at rest or moves with constant speed. Weight is mg. Weight is mg. N is the normal reaction. So if it is at rest, acceleration equals to 0. So N equals to mg. Apparent weight of person in a lift equals to mg. N is apparent weight of person in a lift. So N equals to how much? N equals to mg. Lift is at rest or moves with constant speed. Second point, lift moves upward. Lift moves upward with acceleration. Lift moves upward with acceleration. Lift moves upward with acceleration. Normal reaction is N. Weight is mg. Lift moves upward with acceleration. So lift moves upward with acceleration. So N minus mg equals to ma. n equals to m whole g plus a. N minus mg equals to ma. N equals to m whole g plus a. So apparent weight of person in a lift increases. Apparent weight of person in a lift increases. Apparent weight of person increases. So that is related to motion in a lift. Lift moves upward with constant speed. Lift moves upward with acceleration. Next is lift moves downward with acceleration. Lift moves downward with acceleration. So this is the lift. N is the reaction. Weight is mg. Lift moves downward with acceleration. So mg minus n equals to ma. N equals to m g minus a. Apparent weight of person in a lift decreases. Apparent weight of person in a lift decreases. N equals to m whole into g minus a. Apparent weight of person in a lift decreases. Lift is in a case of free fall. Lift is in a case of free fall. The lift is in a case of free fall. The lift is in a case of free fall. The say case A equals to G. Lift is in a case of free fall. That A equals to G. That A equals to G hele. If A equals to G, N equals to M, G minus G. So that equals to 0. As apparent weight of person in a lift is 0, so lift is in a case of free fall. As lift is in a case of free fall, apparent weight of person in a lift equals to 0. So these are the conditions related to motion in a lift.